Is this star still gonna go nova? Remember seeing news last year about a guest star that was gonna appear in late 2024? Well, don't worry, you didn't miss anything just yet. The star is called T Coronæ Borealis, or TCrB, which means it is usually a fainter star in the crown constellation called Coronæ Borealis. It's what's known as a periodic nova, which means that it rapidly brightens for a short period of time, in this case, a few weeks, roughly every 80 years. This is because it's actually two stars, one dense white dwarf accreting or pulling material from a larger red giant. Eventually, so much material, mostly hydrogen, builds up on the denser star, and it explodes in a violent nuclear fusion reaction until the process starts again. The last time this happened with TCrB was in 1946, which means we're due for another one, right? Well, back in 2023, it seemed that the star's decade-long period of extreme accretion was coming to an end, which when looking at the 1946 eruption, seems like this little dip after that brighter period suggested it happening around summer of 2024. But that came and went with no guest star. So now it's starting to seem like there may not be a relationship with this little dip in the way that we thought, but it's probably still happening. Recurrent novae don't have to follow a strict pattern, and with other historical evidence from past eruptions, the nova might happen in November of 2025 or all the way up to January 2027. And with all the accretion it has already done, it seems like TCrB will soon reach the threshold required for an explosion. So what will it look like? Well, it definitely won't be this. These videos talking about what TCrB is gonna look like are not real. A lot of them also call it a supernova, which is not the same thing. Like I showed earlier, the funny part is that even if it were a supernova, it still wouldn't look like this. At least not anywhere close to our planet. If you could see this level of detail with all these nebulous, pretty gas structures, you'd be dead from the radiation pretty fast. On top of those, there's also these videos reportedly showing the star pulsing or getting ready to blow, but these are also beyond exaggerated. Yes, TCrB is a variable star, but that pulsating happens over long periods of time, like weeks or months, not captured in this ridiculously zoomed in and out of focus video. What's actually on screen here is at most atmospheric disturbances, and probably just noise. Side note, these channels also do the same thing with Betelgeuse, like way more often. Betelgeuse is a topic for another day, but these videos are misleading for the same reasons as the Coronæ Borealis ones. Even though the star will go supernova sometime within the next 10,000 years and appear much, much brighter than TCrB, they also had these live streams acting as if it's happening now with just looping footage of the stars. Also be cautious of any articles hyping it up as a cosmic fireworks show or mentioning specific dates. We don't have any way of telling exactly when it's going to happen. Okay, I wanted to get the overhyping out of the way first, because of course, the real deal is just never as cool as the clickbait. But I really hope that fact doesn't make anyone less excited for what is still an amazing thing to witness. When it eventually does go nova, TCrB will be around the second magnitude. That's around Polaris, the North Star, which is not the brightest star in the sky, but it's in the top 50. The best part of this nova's location, though, is that it will appear to be almost, if not the brightest in its constellation, like a jewel in the crown, which is awesome. If you were to see it at the moment it explodes, you'd see a star slowly appear for around an hour or all night. And once it peaks, it will slowly dim again in the coming weeks, giving you some opportunity to go out and see it until it is once again invisible to the naked eye. If you want to know when the nova occurs without having to go out and look up every night, then you can use the American Association of Variable Stars, and they're constantly updating photometric data. To see the data for TCrB, use the link in the description or my comment. Just scroll down and look at this table, where you can see the most recent entries from contributors around the world. It looks a bit intimidating, but you only have to worry about these two middle columns right here. The one on the left shows the date and time of the observation in UTC, and the one on the right shows the brightness or magnitude that was recorded at that time. Like I showed earlier, the lower the number on the magnitude scale, the brighter the object. Usually, this number is somewhere between 11 and 9, but when the nova happens, the magnitude will go past 7 pretty quickly, brightening to a 3 or even 2 after the first days of the eruption. So if you want to know when TCrB is happening, then you can check in with that website daily, weekly, or however many times you find yourself thinking about it again. Well, as I was editing this video, another nova happened in the constellation of Lupus. This is a similar kind of phenomena as TCrB, but it's a different constellation, different nova, and they're not the same thing. So if you see any headlines talking about a new star in the sky, don't worry, that's not TCrB. That hasn't happened yet.